Hello, ladies and gentlemen. My name is Matthias Landgraf. I'm working at and also speaking to you now from Graz University of Technology. Today, I'm going to talk about environmental impacts of railway infrastructure and their potential for mitigation. When we want to assess environmental impacts of any product, process or service, and in this case of railway infrastructure assets, then the best possibility is to use life cycle assessment. Life cycle assessment is clearly defined in European regulations with its principles, frameworks, and how to evaluate and how to execute it. So the big advantage of life cycle assessment is that figures and results in the end are really comparable and transparent. The first big step of life cycle assessment is to define the goal and the scope of the study. So in our case, railway infrastructure assets. The second big part is the inventory analysis. This is a really big part of data collection where we have to assess all the masses which are installed in railway infrastructure, also all the transport and associated processes to it. So this is a really big part of any life cycle assessment. And then as a third step, we have the impact assessment. So there we transfer kilogram concrete, for example, into CO2 equivalents or other impact categories which are associated to the production and construction of these masses of concrete. And the last part, the fourth step, is the interpretation. Interpreting the results, coming to conclusions and recommendations in the end. As the name life cycle assessment already tells us, we deal with the life cycle of a product, and in this case of railway infrastructure. We have to start at the raw materials via production, construction, operation, maintenance, and then we come to the end of life. We should not stop at the end of life. We should really go beyond and really look on what we can recycle in the end, what we can reuse, maybe on site even, with ballast cleaning machines, for example, reusing ballast on site, and to minimize and have a very low amount of masses which we have to dispose in the end. The unit for such a consideration of a life cycle is always mass of, in this case, CO2 equivalent or any other impact category per time, because we want to compare also results which are based on different service lives. So we have to relate it to a time factor in order to be comparable. The big advantages is that we can include the service life, so the longevity and the quality of the products in our considerations, and also that reuse and recyclability is included as well. The big challenge, we need information. We do not only need information about the amount of masses which are installed in our railway infrastructure or railway track, for example. We also need to know how long the track will last under certain boundary conditions, so we need to know the service life. We also need to know how many maintenance measures we have to expect over the service life. And we also need to know what processes are at the end of life and how are the materials dealt with. When we look at Austrian Federal Railways as a whole, so to say, and on a global perspective, then we can calculate, of course, the emissions which are associated to ÖBB's passenger and freight traffic. And we also calculated ourselves the emissions associated to providing, constructing, producing, and maintaining infrastructure. So in this graph, we can see that these are nearly, so to say, 50-50, nearly equal. So this is just to tell you that we must not and we cannot neglect the infrastructure when we talk about environmental impacts in the railway system. There is a lot of research and development going on the right-hand side of this donut graph associated to passenger and freight traffic. We talk about alternative propulsion systems and so on. So there is a lot of research and we can expect mitigating these environmental impacts in the next decades. But infrastructure is kind of neglected up to now. So this is just to emphasize on that railway infrastructure really has a big impact, and what has big impacts has also a big potential for mitigation of environmental impacts. If we look at the different assets now of railway infrastructure, then we can see that track is by far the highest contributor of environmental impacts in terms of CO2 equivalents per year. Of course, if we would look at it on a per kilometer basis, then the tunnels show the highest impacts. But within a network, also in Austria, we have a lot of tunnels since we are an alpine country. But also in Austria, we have way more track kilometers on open track than in tunnels. So within a network, the track is by far the highest contributor of environmental impacts. So this was also the reason why we looked at track very closely and with a detailed approach. Here you can see a comparison of ballasted track with 3 different superstructure types. We have wooden sleepers, concrete sleepers, and concrete sleepers with under sleeper pads. This example is based on a surge in traffic load within a straight section, so that we are comparable in this part. And we can see that despite the additional environmental impacts of producing these under sleeper pad material, concrete sleepers with under sleeper pads show the lowest environmental impacts due to the increased service life. Under sleeper beds can increase the service life by 30%. So this means in a per year assessment, like we do in life cycle assessment, this shows the lowest environmental impacts. I want to show you a quick example of how we can integrate these considerations in a day-to-day business with the example of public procurement and the tendering process. ÖBB's tendering process is based on total costs of ownership. So investment costs, construction costs, and operative expenditures are included. We, together with ÖBB, developed a methodology to also include the costs which are associated to greenhouse gas emissions. So to also include environmental impacts in this calculation within the tendering process. Since we have it then as a cost figure, we can put it on top of the total cost of ownership or integrate it in the total cost of ownership and then have a summed up cost figure which gives us the opportunity to then choose the best offer within the tendering process. The environmental impacts are calculated based on offer-specific information from the bidders, so like masses, transport types, distances, processes, and so on. And they're calculated with greenhouse gas emissions of the production, construction, and operation. And this is then multiplied with a monetization figure, a monetization factor, in order to transfer it from greenhouse gas emissions to a cost factor. Just a very short example. We look at 2 scenarios here for rails. Both scenarios have the same traffic load, sleeper type, rail profile, and they are both situated in a narrow curve with 250 to 400 meters radius, but they differ in the steel grade. One has a higher steel grade than the other, so this means with the higher steel grade we have a lower number of rail exchange, which is necessary throughout the service life, and a lower number of rail surface treatment, which is necessary throughout the service life. And this shows us that with the scenario 2, with the higher steel grade, we can save up to 40% of greenhouse gas emissions associated to rails when we use the higher steel grade. So to sum it up in the end, what are, from my perspective at least, the potentials for mitigation of environmental impacts for railway infrastructure? The first big part is service life. If you just think about it, if we can double the service life, then this means that we just need half of the masses, half of the raw materials, half of the production process, and so on. So service life plays a big role. Then we should put our effort into research and development of low emission production processes, especially for steel and concrete, because these 2 are the main contributors in the railway infrastructure. We should adopt circular economy, so install masses with a high potential of reuse and recycling, best case on site, because like with the example of ballast cleaning, we can reuse the ballast stones on site, and we also save the environmental impacts which are associated to the transports. We should include environmental impacts in decision making, for example in the tendering process. And we should also involve an environmental pricing scheme on a European level so that we can transfer environmental impacts into cost figures. So then they are becoming a hard cost factor, so to say, and it really becomes a business case for companies to reduce environmental impacts within their production processes.